Hey guys, welcome back to week 2 of distance learning. So last week we looked at exponential growth, and today and tomorrow we're going to take a look at exponential decay. Remember, just a couple reminders, you can write these down or you don't have to, but remember if you were doing growth by a factor of 5%, that was your 100% plus 5%, which gave you 105%, so we called that a factor of 1.05. Double would be multiply by 2, so that was our factor. And then if it's growth by a half, that's 100% plus 50%, or 1 plus 1/2, so 1.5 is my growth factor. Okay, basically what we're going to be looking at today is the reverse of that. So instead of growing, it's literally called decaying, but think of it like a sale. Okay, if we found something on sale, my inbox is flooded with sales right now because everybody's trying to get you to still spend your money. If I found a sale and something's marked down 20% off, how much are we actually going to pay of the cost of that item? So in that case, you'd start out with 100% of your cost, you'd take away 20% of the cost, and you're going to spend 80%. So my factor there would be 0.8. Okay, so that's just a little background as we head into our notes. Let me switch colors here because we know I love to do that. Okay, so again, exponential decay. We're going to make a table of values for this equation. 100 times 1/2 to the x power. And remember, order of operations says we have to do half to the x power first, then multiply that answer by 100. So 1/2 to the 0 is 1 times 100. 1/2 to the first is 1/2 times 100. 1/2 to the second is 1/4 times 100. And 1/2 to the third is 1/8 times 100. And so if you then look for the pattern of what's going on the chart, you're going from 100 to 50, 50 to 25, 25 to 12.5. What's happening? You're dividing by 2 or multiply by 1/2 each time. Okay? The other thing that we see about my y values is my y values are getting smaller and smaller and smaller and smaller. Okay, they're decreasing. And so that's what's going to happen in decay. So in growth, our numbers are getting bigger and bigger and bigger, and they get really fast, really big, really fast. And then in decay, our numbers are getting smaller. Okay, so what's the form? The general form for an exponential decay function, it's the same. It's the same as what we looked at last week. A times b to the x minus h. Oops, sorry, that's a minus. X minus h plus k. And of course, h still represents your right or left shift. K still represents your up and down shift. And then A is your initial value. And B is your, now instead of being a growth factor, it's a decay factor. But what's the difference between a growth and decay factor? If it's a decay factor, it's between 0 and 1. It's going to be like 0.5, 0.75, 0.9, 0.26, whatever that is. Okay? The other thing is there's a lot of our equations that won't even have an h and a k in them. Okay, so again, just like on our sale, right, how do we find the decay rate? Well, you're going to take 100% minus your rate. To do it in decimals instead of percentages. B equals 1 minus R. Okay, and R is a decimal. Okay, so in here, 3%, B is going to equal 1 minus 0.03, or 0.97, 97%. For the 40%, B equals 1 minus 0.4, so 0.6. And then if something is losing a quarter, what does that mean? That means it's a decay by 25%. So B equals 1 minus 0.25, or 0.75. So again, these are just like if you got it on sale, what's going to happen? Now, what if instead of giving us these numbers, what if they give us a table instead? Because they like to do that a lot. Okay, well, as you remember, most of our equations are going to be in this form. So how do you get the A? Well, when x is 0, A times B to the 0 power, remember, just like from last week, B to the 0 power is 1. Anything to the 0 power except 0 is 1. So if you did the 0 power, that gives you the A value. So on here, A equals 320. How do you figure out then the decay factor? Just like we did last week on the chart with the growth factor. What's the pattern you see? And there's a couple ways we can express that. You might see right away that these are being divided by 4 each time. Okay? That's the same thing as multiplying by 1/4. If for whatever reason you didn't see that, you can get your B value just by taking and dividing the second number by the first number. And you're going to get 1/4. So what's our equation? Y equals 320 times 1/4 to the x power. Or if you prefer, you can say y equals 320 times 0.25 to the x power. I will accept either one of those. I don't care if it's the decimal or fraction. If you were taking ACT or SAT, if you got one, you would know that the other means the same thing. Okay, so now this is where we start looking at the ones that have an H or a K value. And so what is it telling you? Well, this one is telling you two things. One, it's going to reflect over the X. And the second thing it's going to tell you is it's going to go left 2. So if you knew where the parent function was, okay, you can just move that function. And so the parent on this is 12 times 1/3, whoops, 1/3 to the x. Of course, you can make a little XY chart for that. -1, 0, 1, 2, and I'm just plugging in. If I plug in -1, I get 36. If I plug in 0, I get 12. If I plug in 1, I get 4. If I plug in 2, I get 1 1/3. Michael, you can check my math on that. Okay, then I'm going to graph those. So as you see, it's just sort of, it's the reverse of that graph that we looked at last week. Okay, so now what happens? I take any of my points over here, I move them left 2, and I flip it across the axis. So here I go 1, 2, flip across the axis. Here I go 1, 2, flip across the axis. 1, 2, flip across the axis. 1, 2, flip across the axis. And I'm going to get that new pink graph. Now, could you have just made an XY chart and plugged in with the first one? Absolutely. It's just sometimes a little bit harder to get the version of where is your initial value going to be. Okay. The other thing, question on here says, what is an asymptote? We talked about that last week, of course. And again, besides being Alberto, an asymptote is that little line where your graph does not cross. Okay, it's like when we talk about walking halfway to the wall. Will I ever, in theory, hit the wall if I go halfway each time? No. Okay. Okay, so one more example here. Let's see, what's this one going to do? Two things happening. This is going to move right 4 and up 5. Okay, what's the parent graph on this one? Parent graph is y equals 1/2 x to the x power. If I made my little XY chart for the parent, -1, 0, 1, 2. And if I plugged them in, I'm going to get 2, 1, 1/2, and 1/4. Luke and Ethan, you're distracting me. Shh. Okay, so I graphed that one. And now what happens with all these points? They move right 4, 1, 2, 3, 4, and up 1, 2, 3, 4, 5. Right 4, 1, 2, 3, 4, up 1, 2, 3, 4, 5. This is way better if I would have had graph paper on here, but 1, 2, 3, 4, 1, 2, 3, 4, 5, 4, and up 5. And so shape's the same. Now, where's my asymptote on here, though? That is the only key. Well, my asymptote on the original one is at 0. If I moved this graph up 5 places, guess where my new asymptote is going to be? At y equals 5. Okay, hopefully that makes sense to you guys. There's posted a homework assignment for you, and let me know if you have any questions. And I'll be back again with another one soon.